So welcome to TPCM once again, the second part of complex numbers for diploma students. So this is a continuation of the next previous video. So the next concept is exponential form of the complex number. Exponential form. Simple. We are now going to discuss more definitely. So exponential form of x plus iy is e into I power theta, r into e power I theta, where e power minus e power I theta is nothing but x plus iy is equals to r into e power I theta. We know that already. Cos theta plus I sin theta. Cos theta plus I sin theta. Wherever x is equal to r cos theta and y is equal to r sin theta, we discussed in the previous cases. That is e power I theta. Then we can go for e power minus theta, means minus I theta. Also cos theta minus e power minus I theta can be written as r of cos theta minus I sin theta. You can follow this one also, no problem. And we'll have some definitions we'll discuss in the future. In the definition directly we'll go for problematic. Some problems we'll discuss today. And before going that, we have some formulas. That is sin of x plus iy. Sin of a plus b we know already. Then we should follow the same thing. That is sin x plus sin x cos y plus cos x sin y sin iy. We have to use the same thing for cos sin and cos sin x and cos x also. We can follow this one. So based on formula we'll go for the, sorry, based on problems we'll go for formula, right? So we have to discuss now solved problems. We'll go for solved problems now. So first form is convert anything into a plus ib form. So he will give you one question and we have to convert into a plus ib. That is, for example, 2 plus 5i by 4 minus 3i. So what is the concept here? What is the concept? 2 plus 5i is a complex number which is dividing by 4 minus 3i. We have to divide. So before going to this concept, already we learned that if you want to divide a complex number with other complex number, we should go with the rationalization method. The word is a conjugate of 4 minus 3i, 4 plus 3i and 4 plus 3i. Now multiply this one. If you multiply this one, automatically it will convert to the a plus ib form without knowing. So only one concept should learn, that is in the down, that is in the denominator, we should not have the complex number. In the down, that is in the denominator, we should not have a complex number. If you see the complex number in the denominator, try to eliminate it. How to eliminate it? Rationalization factor. So the rationalization with the conjugate number, right? So now see, that is 2 plus 5i into 4 plus 3i is divided by 4 minus 3i into 4 plus 3i. Now multiply. 2 4s are 8 plus 2 3s are 6i plus 5 4s are 20i plus 5 3s are 15i square. This time I am writing I square. Next time I will go for directly minus 15. A minus b into a plus b, a square minus b square, that is 3i whole square. 8 minus 15, or shall I go one more method? 6i plus 1 26i minus 15, because I square gives you minus 1. 15 into minus 1, 15 minus 15 by 4 square is 16. 3i square means 9 minus 9 minus 9, that is minus of minus 9 plus 9, that is 8. Sorry, we can go for 8 minus 15 is minus 7, I think so. Minus 7 plus 26i by 25. This is, now you can observe, we should write a plus ib form, no? So this is called plus I into 26 by 25, where a is equals to minus 7 by 25 and where b is equals to 26 by 25. See here, we converted the down one, we converted into the normal form, that is a plus ib. That is normal form a plus ib. We'll go for one more question based on this same concept. So suppose that 1 plus I by 1 minus I whole square, whole cube will go. minus 1 minus I by 1 plus I whole cube. We should convert in the form of a plus ib. We should convert it into a plus ib. That means entire this equation should be in the form of a plus ib, right? So that means what is our concept? If you see the complex number in the denominator, try to eliminate it. Try to eliminate it. That is 1 plus I by 1 minus I into 1 plus I by 1 plus I, because the conjugate of 1 minus I is 1 plus I whole cube, minus 1 minus I by 1 plus I into 1 minus I by 1 minus I whole cube. Now just expand this one. 1 plus I whole square, otherwise you can go with directly also 1 plus I. Shall I go with 1 plus I whole square? Because a minus a plus b whole square, a minus b into a plus b, so a square minus b square, 1 square minus I whole square, okay, whole cube, minus 1 minus I whole square by a plus b, this is a minus b, that is 1 square, and minus how much? I square whole cube. 1 plus I square, we know that a plus b whole square, a square plus b square, right, a square plus b square plus 2ab by 1 square plus 1 whole cube minus a square plus b square I square minus 2ab by 1 plus 1 whole cube, because I square gives you 1 minus 1, but minus I square gives you plus 1, don't forget it, right? So 1 minus 1, 1 plus I square always 0. Wherever you see this 1 plus I square, definitely put 0. No need to go for, because I square is minus 1, 1 minus 1 is 0. Then I'll go with the 2i by 2 plus 2 is 2. Sorry, 1 plus 1 is 2 whole cube minus 0. I don't want this. 2i by 2 whole cube. 2 to get cancelled and 2 to get cancelled. Here I'll have I3 minus of minus I whole power 3. Listen, I power 3 minus, you see minus I whole cube means minus I into minus I into minus I. Can I write this minus I into minus I into minus I minus I cube, then I cube minus into minus plus I cube, that is 2 I cube, that is 2 into I cube can be written as I square into I, that is 2 into I square gives you minus 1 into I, that is minus 2i, that can be written as 0 minus 2i, and that can be written as 0 plus of minus 2 into I. Why we are writing like this? Because it's asking in the form of a plus ib. That means we should write the value of a is 0, then the value of b is minus 2. Otherwise, if you are using x plus iy, then you can go for x is equal to 0 and y is equals to minus 2. That means it is in the form of a plus ib. But in the question, in the textbook of diploma also, they are asking in a plus ib only. So you can use different cases, right? We'll go, so all the maximum, there are only one concept. If you have the complex number in the denominator, you can simply eliminate it, or you can simply do rationalization. So we have one more one. Find the real and imaginary parts of the following. Same thing here, same is asking the concept, that is 4 plus 2i by 1 minus 2i plus 3 plus 4i by 2 plus 3i. So for this is asking the concept. So is asking only the real part and imaginary part. Okay, before going to write that, first we should check, is there the complex number in the denominator? Yes, we have denominator in the complex number. We have complex number in the denominator. So try to eliminate it first. Later we'll discuss. So that is 4 plus 2i into 1 plus 2i, because the conjugate of 1 minus 2i is 1 plus 2i. So 1 minus 2i. Now I'll use the simpler, just a short form, so that to make it easy, that is 2 minus 3i by 2 plus 3i into 2 minus 3i. 4 ones are 4 plus 4 twos are 8i plus 2i. 2 twos are 4. Okay, I write 4. I square gives you minus by a plus b into a minus b, a square minus b square, 1 minus 2i whole square. So now I'll write this time, plus 3 2 is 6 minus 9i plus 8i minus 4 3 is 12. I square gives you minus 1, then plus, I'll go with that, a plus b and minus b, 2 whole square minus 3i whole square, 4 minus, sorry, these two are get cancelled, 10i by I square gives you plus 1, 1 plus 4 5, plus 6 plus 12 is 18, minus I think so, by 2 square gives you 4. Can I go for directly? Yes, 2 4, and here plus 9 you will get. Here you will get plus 9. 9 plus 4 is 13. Now you can go for LCM, or 5 ones are 5 twos are. That is, you will get 2y plus 18 minus I by 13. Now it is in the fraction format. Just go with the cross multiplication or go for LCM. That is 26I plus 18 minus I by 13. Then you will have a 26 minus I. That is 25I plus 18 by 13. Otherwise, it is should be in the form of a plus ib, that is 25 by 13 into I, where a is equals to 18 by 13 and b is 25 by 13. So this we have to discuss. Now you can write the real part. A real part, this is real part, is asking real part. No, this is real part, and imaginary part means this one. Don't confuse here, because if you take x plus y as a complex number, where x is the real part and y is the imaginary part, so sometimes we'll ask like this: a plus ib, then convert into a plus ib, or sometimes we may ask x plus, find the value of x and y, or sometimes we may ask find the real part and imaginary part when we compare this question.